What's up everyone, this is Matthew. Welcome to a new video. In this video we are going to find out the difference between AC and DC. Where AC is nothing but alternating current. While considering the waveform, we can see that there is an alternating waveform or a synchronous waveform. It's nothing but because of the flow of electron will always reverse periodically. Which means if we have a 230 volt 50 Hz AC supply, the current will move forward and backward 50 times a second. While considering a graph of an alternating current, if we start from zero, for a certain period of time, current increases maximum in the positive direction, and after that it get reduced to zero. Then after that the current increases maximum in the negative direction and it moves back to zero. While considering DC is nothing but direct current. The DC supply do not change its direction during the current flow and always remains constant. The waveform of DC supply always will be a straight line. In major power plants like hydroelectric, thermal, nuclear power plant, windmill, etc., AC supply is generated by using special types of generator called alternators. The major source of DC supply is fuel cells. Because of the chemical reactions going on inside them will create a polarization between two terminals. And also from the solar cell, UV radiations from the sun captured in the solar cell and converted it into solar photovoltaic current and supplied it to a battery. The AC loads can be either capacitive, inductive or resistive loads. But while considering DC, there will always be resistive load. There will not be inductive or capacitive loads. Nowadays we are using HVAC and DC transmissions. HVAC is more commonly used, but we use HVDC only for certain purpose because AC transmission is more simple, easy and efficient, and for DC there are lots of disadvantages. For example, converting AC voltage is pretty much easy while considering the same thing on DC supply because we can easily use transformers in AC supply. Also, the protective devices such as circuit breakers are more expensive for DC transmission, and also we require a separate power system for DC transmission. So we are using different electronic devices such as smartphones, laptops, computers, electric bulbs. From where we are getting this DC supply from? We are converting the AC supply to DC to use these electronic devices. The device which is used to convert AC to DC is called rectifiers, and here I can show you the circuit diagram of a rectifier. Okay, so what's happening in here is the 230 volt. If we want a 12 volt DC supply, the 230 volt from the main source is stepped down to 12 volt AC supply by using this transformer, and the output of the transformer is connected to a bridge rectifier which is made of diodes, and from the bridge rectifier output we can take 12 volt DC supply, and that's how we are generating DC from an AC source. We can also use a voltage regulator at the output of the circuit to get a constant voltage output. In certain homes we have inverters. What's happening inside it is, first we are converting the AC to 230 volt AC supply to DC and stores in a battery, and after that when the power is gone, the DC supply from the battery is converted into AC source by using inverter, and this 230 volt is supplied to the main supply. That's how inverters work. While comparing devices which work in AC and DC, the DC devices such as DC motors, DC bulb are comparatively more efficient than AC devices. So DC is more efficient than AC and it is more easy to control. But the main problem is in the transmission of DC supply. And that's why we are still using AC. So that's it for today's video. Hope you learned something. If you like it, give me a thumbs up and comment down your suggestions or questions or any doubts regarding this field, and do subscribe so that you won't miss another informative video. See you then. Bye bye.